Algebra students, Mr. Lawrence here, and we're getting ready for our quiz. This video will have 4 different types of transformations. You'll have to tell me what they did, okay? Shouldn't be a very long video. If you can identify somebody else's transformation, you should be able to do them on your own, recognizing what has happened. So that's why we're doing it this way. The quiz is Wednesday. You'll be watching this Monday night. Of course, it'll be there for review if you need it. But let's get down to it. Here I have problem number 1. Okay. Now, trying to figure out what happened. It should be clear that it rotated. This arrowhead kind of shape was pointing left, and now it's pointing down. It moved from one quadrant to another quadrant. It should be some type of rotation. I'm guessing it's going to be a counterclockwise rotation. If you're still having trouble with counterclockwise, then you better come and see me. Okay, now, I'm guessing it's a 90-degree rotation, but I better check. Let's see here. What are the coordinates of this point right here? They are at 1, 4. 1, 2, 3, 4. Yes, 1, 4. If I rotate 90 degrees, the new point should, let's see, 4 and 1 should switch places. I'm going counterclockwise, so I'm going from quadrant 1, where both terms are positive, to quadrant 2, where the x is negative and the y is positive. So I should have a negative x and a positive 1. 1, 2, 3, 4, 1. Now, remember in class, I might have mentioned that just one point isn't going to assure me that I've got the right thing. I've got to check another point. Let's check this one right here. Okay, let me get back to Poyple. Sorry about that. That looks like it's at the point 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is at 5, 5. I switch the two 5s. I make the x negative, and I should get negative 5, positive 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and look, there it is. Okay, now if you want, instead of just doing coordinates, you can check. From here, I go up 2 over 1 to the right. Well, I've got to go up 1, left 2. Okay, and then down 2, right 1. And look, I'm running into these points. So this is a 90-degree rotation. And it is counterclockwise. There you go, counterclockwise. All right, feel free to pause the video at any time and try to figure out. Too many of you just kind of watch the videos and you don't stop and think. All right, let's get on with problem number 2 here. And we had the original shape was the black one. It's triangle PQR. And then we have this little red triangle here. Hopefully you can see those. Sorry about that. Made a little stray mark on there. All right, let's see what's going on here. Well, it definitely changed size. It looks like the big one shrunk down to P, didn't it? All right, let's see. How long was this horizontal side? 1, 2, 3, 4, 5, 6, 7, 8. How long is this side here? Well, it's 4. Uh-oh, it looks like my scale factor might be 1/2. How did I get 1/2? 8, the original length, PR, times the scale factor equals 4. Oh, divide by 8 to get the scale factor alone. The scale factor equals 4/8 or 1/2. Okay, now, just because I have it one time doesn't mean I've done it correctly. Let's check something else out. Let's check the heights. The height of this triangle looks like it's 1, 2, 3, 4, 5, 6 units long. And the height of the littler triangle looks like an awful big bulky mess. Let me shrink him down. Come on, properties. There we go. Okay, looks like it might be 1, 2, 3. Oh, so the height was 6 and it went down to 3. Well, what's 6 times 1/2? It's 3, of course. So the height reduced by the same amount. Another interesting thing is, check this out. It went 1, 2, 3. The height hits the base at 3 units from P. Well, since the scale factor is 1/2, the height of the little triangle hits the base 1.5 units. because 3 times a half is 1 1/2, right? 3 times 1/2 equals 1 1/2. 3 halves, and that's the same as 1/2. 1 and 1/2, excuse me. All right, so this is a dilation with a scale factor 2 about point P. Okay, I know some of you are having some trouble with that. All right, problem number 3 here. We have the black diamond kind of shape. It's not a perfect diamond. Excuse me. And we have the red shape inside. It looks like some type of dilation has taken place. Let's see if we can determine the scale factor. That might be a little bit trickier. Maybe we should determine what the center is. I think the center was the origin. Yeah, the center is the origin. And let me count the diagonals. Let's see, this went 1, 2, 3, 4, 5, 6. And the right one went 1, 2, 3. Big one was 6, little one was 3. Across 1, 2, 3, 4, 5, 6. This one's hard to cross because it's not even, but there's a half, 1 1/2, 2 1/2, another half makes 3. 6, 3 again. Very interesting. Let's check some coordinates. Let's see here. This 1, 2, 3, 1 is the point 3, 1. Now the one here corresponding to it looks like it's the point 1 1/2, 1/2. What could I do to these two numbers? 3 times blank equals 1.5, 1/2. Okay, 1 times blank equals 1/2. Well, the answer must be 1/2, right? Yeah, this is a dilation Okay, the center is the origin, and the scale factor is 1/2. All right, last problem we're going to check out is this one here. Hopefully you can tell it's a reflection. Remember, the key with the reflection is finding the mirror. If you have trouble finding the mirror, take a pencil, take something thin, and put it onto your paper. Okay, and see if you can put the mirror in the right place. Now, if you were listening to Hannah Urich in class the other day, I think it was actually today if you're listening, she knew they had to be equidistant. So I'm going to put it so the mirror is in between the two noses of these birds. Can you see a bird here? Okay, maybe there's the eye here, there's the beak, okay, some feathers going back, tail down here. Well, this bird, the black one, okay, so I'm going to put it in between the beaks. I mean, if you need to, draw pictures out of them so they make sense. You know, you got your eye here, okay, there's the beak, there's the feathers, and this is the tail. All right, and then of course the eye would be here, and there's the beak, there's my feathers, and of course the tail. All right, so it looks like it's smack in here, and this one here is the line x equals -1. This line here is the line x equals -2. So the mirror must be x equals -1.5. So it's a reflection with the mirror at x equals -1.5. And there you go. All right, that's the video tonight. We'll be taking the quiz on Wednesday. Mr. Lawrence signing off. Have a good night, everybody. Hey.